Hello guys and welcome to part 16, I think it is, of the UBIK solution. In this video I want to go back to looking at how we can set the shoulder rotation from the hand's position relative to the head. And if you might remember that I did a very simple version of this a few videos back, where I said I have this set shoulder, this one here, recall, and it has two components. It will get a contribution from how you rotate your head, but also how you have your hands relative to your shoulders. And this is the part that we're going to change today here. And while I remember this, make sure you check this box here, this shortest path checkbox. You need to set the shortest path checkbox to be checked. Otherwise, we're gonna get kind of a jump in a certain rotation, and I forgot to do that when I did it. Just make sure to set this checkbox. What we're also gonna do is to start off by getting rid of these variables in here, because technically we're gonna do it in a different way for now. We're just gonna set them inside, is what I'm trying to say. So that means the signature of the function is going to look like this. So if we go inside here, we can get rid of these two vectors here, and the rest of this we're actually for now just going to disconnect and put it down here. We're going to move this inside its own separate function in a moment. And the logic that we are going to build, I'm just going to spend a few minutes explaining what we're going to do, and hopefully it will make a little bit more sense. So if we have the head here looking from above, and the head is going to have a forward vector pointing this direction here. So the hands, they can generally, if you just look at it from above, they can be anywhere on this circle here. And what I'm going to build today is a way to say if the hands pass a certain a limit here and here, then I don't want the hands to have any more contribution to the rotation of the upper body, basically. So the angles that I chose for this is going to be minus 150 and 150. And once because your hand can actually pass all the way around, and you might wonder, how the hell can I do that? Yeah, I can only move my hand like this, but you can actually move it if you circle your hand above your head. Then you can actually move 360 degrees. So that is kind of a funny case. So once you return, if you move your hand in a circle, once you pass this point here, then it's gonna stay here at that point. But you can, as I say, continue that motion all the way around here. So when do we actually start to get some rotation contribution from the hand? Again, that is what we want to express with another limit here. And that is going to be something like 80 degrees. Could say this, set this to 90 degrees, but that means that we can only pass our hand to a certain extent on the other side here. Past that point, it's not really gonna do anything. So. Whoops, I'm just gonna color let's call it the dead zone area here blue, and then we're gonna have let's give it a green color. Inside this area, the green area is gonna be the safe other safe zone. Yeah, so what happens when you enter all in the white areas here is that it's gonna still have an effect. So let's give it a like this other color here. So inside this area here is also gonna have an effect, but inside the blue it's not. So I'm gonna not have an effect. Okay, anyway, so we have a lot of stuff to cover today, so I'm gonna start building the logic here. Hopefully it will make sense. So we are inside the get shoulder rotation from hands, and we need to start off by converting the hands location into head space. So we do that by first taking the head effector and we invert that. Always remember, when you then compose something, and whatever you want to compose, if you have it in world space, then it needs to be at the top here. So this one needs to be at the top, and this is the inverted. So what we will get out here is the hand in head space. So we need to do this both for the left and for the right hand. This one here. And we are going to use also two other angles here. So we have a left hand and a right hand angle. They're going to be different. So, and since we need these still, and they were used for elbow, I'm just going to rename these so we don't mistake them from each other. Elbow, and this will be elbow as well. Actually, this one, let me just move the elbow to the beginning here. Okay, so we need to create two more variables, one for the left, but this time for the head. It's related to the head. That's what I'm trying to say here. There we go. And while we are creating variables here, let's also create the two. Actually, it will be three, but I'm gonna explain that. Variables here. So we have a setting called, what did I call it? Head and angle. Head, hand, angle limit. I'm just gonna make it public so I can see this is a setting. It doesn't really serve any purpose other than that, just to visually tell myself that it's a setting. And then we have the head, hand, angle, OK span. Okay, so this is the OK span is what I defined on the drawing as the green area here, and the other one limit is the 150. So the angle OK span will be 80, and this one will be 150. And I'm just going to duplicate this one and remove the I from this one and call it dot, because we're going to use a dot product at some point, and which we will compare against, and we might as well just cache that value here, and we can do that inside the calibrate function here, which is going to get called at the beginning of begin play, I think, currently. If we open this one up, you can see that the begin play calls the UBIK component calibrate. So this is where we will put this logic here. So that means we're going to set this and take the angle limit, which is 150, and then do a cosine cosine in degrees. So it takes a returns a cosine of a in degrees, expects in degrees. So this is degrees, so that will go in here. And if you're wondering what this value will be, it's going to be something like minus 0.8 or something. Means it's if you compare forward vector against whatever some other vector, it's going to be this area behind here somewhere. Going back to get shoulder here. So let's make use of the left head hand angle and the right head hand angle. So we need to set these here, and the right head hand angle, set it here, like so, and like so. And probably need to move it over a little bit, all of it just a little bit, so I have some space. And then we're going to create a function that contains this stuff here. Now we're going to encapsulate this inside a function here. So let's cut that and make a new function we will call get head hand angle. So for now, let's just paste this code in here so we don't lose it, and then do a return. Then it's gonna return our angle here. And the angle I'm talking about, keep talking about, is the if you perceive the hand, just one of them, regarding to or in relation to the forward vector. So you have a hand out here. Whoops. If you have a hand somewhere out here, then you have a vector going here. So it's this angle here we're talking about, trying to find. Okay. And yeah, going back in quick. As you can tell from the drawing here, the hand can move this way, or it can actually also move the other way. Could actually move this way. That means we have to know if we are moving in one direction or the other direction. That means that we have to keep track of the last angle so we can compare, say, the sign, because the sign is going to be changing here at minus, plus minus. So here it's going to be 180, and right next to it's going to be minus 180. So we need to know if it's moving the one or the other way. I'm pointing at my table, obviously you can see that. So what I'm trying to say is that we need to get a last angle here. And then we also need to get the hand position, which is a vector. So this is the, let's make it pure and compile and save, and then set shoulder, no, get shoulder rotation. We can just call it like this. So pass in the angle here, and we need to also get the left head hand angle here. And then we need the location. Currently we have a transform, so let's split it open and just pass in the location. So this is what we need to do for the left hand, and we need to do the same for the right. So split this one open, call our get head hand angle function, and get the right head hand angle. This and this. And this is gonna give us two angles to work with. So we basically need to take the average between these two at the end here, get this, add it together with the right one, and divide it by 2. And this is going to give us a rotator, or the yaw. So make a rotator. So pass it into the yaw here. And you might think, well, then we can just return it like this. But if you remember, set shoulder, This is going to be a component, as you can see from the C here. It's going to be a component rotator, component space rotator. So we actually need to convert this into component space, and currently we have it in head space because we have everything in head space here, which just made the calculation a little bit easier. So we need to convert this. So make a transform, and there might be a easier way to do this, but this is the most straightforward way I can think of. So make a transform and convert this, compose, this with the head effector in world space. This will put it back into world space. So now it's back in world space, and then we convert it into component space. Those, and we have the component transform here in world space. That transform we will invert, just like we did. Remember when we did the transformation inside this one here? Sorry, here when we have the head effector in world space, we invert it and then we compose it with the world transform. So this is basically the same we do inside here. At the end here, we take the component transform in world space, invert it, and then compose that with the world space transform. And this time it's just with the rotator. Break this out, and then so this is now in component space, and this is what we return from this function here. So this is the structure of this. So all we need to do now, and this is basically the main part of this video here, really, and we already spent 17 minutes, so I'm gonna have to speed up a little bit, otherwise it's gonna be taking too long. The last angle here we need to use as a reference later on. I don't need to do this, but I'm gonna do it anyway. Promote this to a local variable here. Call this last angle. And then we need to take the head. We're gonna need that in a moment. Let's see. We're gonna isolate the x and the y, and just ignore the c here. What did I do? Okay, so take this one out, and then we're gonna recombine this and normalize this. So this is just the x and the y component normalized, and we're going to do a break of this and basically do the same as we did before, x to the x and y to the y, and that will give us a rotator. Well, for now we're just gonna take this one out because we don't do a rotator as the end result here. But this we're gonna promote to a local variable and call this angle, L angle, like this. So this is one angle that we could return just like this, but there's more. We will do a select float, and we can maybe change this later on, but for now I'm just going to make the simple version again. One component could be the A, and the other component, if it's getting stuck at one of the limits, that this is what we want to return otherwise. And we get this by taking the head-hand angle limit. And again here we will have to multiply this by whatever the last angle was, or the sine of this. So take the sine of this, so if it's negative then it's negative angle, and otherwise it's going to be the positive angle. Move this a little bit out of the way. So it means if we move this way, it's going to stick to this. If we move this way, it's going to stick to the positive version. This is what we do here. And now we just have to figure out how to pick this. And there are going to be two conditions. One condition is based off the dot product between this normalized vector here. So we do a dot product against the forward vector. Forward. Oh. And if you're wondering why the forward, well, it's because we converted everything into headspace. This is why it's convenient to do it in headspace, because that means we can just compare or dot against the forward vector. So that was mainly the reason why I did this. So if it's greater than, and now we use our head-hand angle limit dot, the variable here that we calculate minus 0.8 or something, depending on what value you use. If it's greater than this, then we are okay. And two things. One of them is going to be saying, well, the last angle sign should be the same as the current sign. So this is one indicator, or whatever you would call it. So if this and the angle, if they have the same sign, we say equal. Do I need more space for this? I might. Or I can just move everything over here. Let's see. I'm going to do it this way. And then we need to check if it's within the safe zone, this okay span here. So within this and this. That means the logic will be the angle has to be less than the okay span and bigger or greater than the okay span, well, multiplied by -1. So this one multiplied by -1. This one. And that should be it. So you can clean this up yourself afterwards. I think that is what we need to do. This should work, I hope. If you just hit play and give it a test. You can see it turns the upper body. We can see this vector here is turning when I move the hand. And once I pass at this point here, it stops to have an effect. Once I pass all the way over to the other side, it should snap. There we go. Now it has an effect again. And that is what we expect. So that means we can also turn the other way, stops having an effect. And once we pass back, snap, it starts to behave correctly again. So obviously it doesn't look nice with that snap, but that is something we will handle in a different video, or in the next video, I believe. I'll make a handling of that. But this is kind of the groundwork for this implementation, and I don't know if I mentioned this, but Matthias Parcher, he did it in a completely different way. So if you're interested in doing it that way, feel free to do so. But as far as I could tell, it had an edge case which would cause the upper body to be positioned sideways, and it would kind of get stuck there, and I couldn't figure out what was wrong with it. So instead of being able to fix it, I came up with this alternative way of doing it here. So it was a little bit rushed, but I kind of felt I had to speed this up a little bit. As mentioned, feel free to leave a comment in on the video if there's something with this solution that you completely not understand, and I will try to explain it or include it in the next video if you're quick, because I'm actually gonna try and record the rest of it in a moment here. Yes, so I guess I will be seeing you in the next. Bye.